Welcome to Accelerated Math 108, Module 9.4, Working with Formulas. A lot of students ask me, why don't I write solving equation the same way as their high school teacher does? And one of the reasons why is when it comes to solving the equation involving with formulas, it's kind of hard to explain why we plus something on both sides or why we subtract something on both sides. I find that over the years, it's easier to show students to treat algebra by looking at them as individual terms, where we can move them to the right, to the left, across the equal sign. So basically, what we're going to do here is exactly the same thing as in the previous three lecture videos, module 9.1, 9.2, and 9.3, except now we're just going to work with some formulas. So here, you can, if you look at this on your lecture handouts, we got ourselves a simple interest formula, temperature formula, distance formula as well, perimeter rectangle, lateral surface area, the force, sum of the angles of a triangle simply means three angles together equal to 180, and the perimeter of a triangle. So these are just some examples of formulas that we are going to see throughout this class. Maybe some of them you already seen before with other courses. So I'm gonna show you how to do this very first example by using three different steps, and I got other examples where we don't have to do all three steps. We're just basically solving for specific variable. So the perimeter of a rectangle is 34 feet. So this problem already told me all four sides together is 34 feet. The length is 5 feet. Find the width. So step one of three want me to choose a correct formula. So since I'm dealing with perimeter of a rectangle, I got to choose P equal to 2L plus 2W. That's the one I will choose. 2L plus 2W. So step 2 of 3 says without substitution, that means without substituting the 5 feet for length, 34 feet for P, solve for the formula for the unknown variable. So the unknown variable here is the width, because the problem wants me to find the width. So here is how it goes, okay? If you look at this equation, right now I got three terms. Addition sign outside the parentheses, separate between two terms. The left side, I got one term. I want to solve for W because W is my unknown. So all of the three terms, none of them has parentheses, so I don't have to worry about any distributive property. No like term to combine on the right side. So step number 4, find your variable term, which is positive 2W. Since it's positive, we're going to let it stay on this side. So that means I move my 2L over. So my equation now should say 2W still 2W on the right. Equal sign in the middle, P still P. When when the positive 2L move over to the left side, it becomes negative. So now there's still no like term to combine here. So that means the very last step is always divided by the coefficient. So whenever we are able to isolate the variable term on one side, no more like term to combine, no parenthesis, none of that, then it must be time to divide it by the coefficient. So here I'm going to say divide every term. The way I say it is divide every term by the coefficient 2. So that means my W would now equal to P over 2, or P half. It's the same as saying half P. Okay, this is the second term. So 2 over 2 would just end up with an L because it canceled out, become 1. So that will be half P minus L. Okay, so this is normally the way I show students when we must divide every term by the coefficient. Now step 3 of 3, finally solve the problem by substituting the appropriate values. So I'm gonna also take this opportunity to key this in the calculator to show you how to do it. So my W, I hope it's okay. I write my W now on the left side because it's the same thing, right? You read it from the right, W equal. You read it from the left, also say W equal half P minus L. So I'm gonna substitute 34 for P. Where did I get a 34 from? Because remember, original problem says perimeter is 34 feet. So half times 34 minus length is 5. So basically, the way we key it in to the calculator is go by the terms. You know the right side, the equal sign has two terms. So when I key it in the calculator, I got to demonstrate there are two terms. So if I say half is zero point 0.5 times parenthesis 34, close it, then say minus 5. The calculator read this as two separate terms, which will give me the right answer, W equal to 12. All right. So sometimes students say, well, Mr. Chen, it does not make a difference if I say negative, if I type in zero point 0.5 times 34 minus 5. That's still going to give me the same answer. Yes, it is true in this case because calculators still see this as two terms because you have a subtraction sign outside the parenthesis. Now, what happens if you accidentally key in this way? Point half or 0.5 times 34 minus 5. Let's say you forgot to close your parenthesis on the 34. Then you come up with something totally different. Okay, so however many terms you see or you write out, we must key in the same way in the scientific or graphing calculator. All right, let's try some other ones. Okay, solving for specific variable. So I'm gonna do this section along with I'm gonna do this objective along with the first one. V equal to L times W times H, solving for L. So I believe this is like a volume formula, solving for L. So how many terms do I have? Two terms because there's no plus or minus sign outside the parenthesis. So my right side is one term, my left side V is one term. So since I only got two terms, my variable term got to be the term that contains the variable, which is LWH. So to get L by itself, being only two terms, no parenthesis, none of that, then the only thing I can do is divide by the coefficient. As you can recall in module 9.1, I mentioned coefficient does not always have to be a number. It can be coefficients are factors inside the variable term other than the variable itself. So in this case, my WH or W times H is my coefficient. So all I'm going to do is divide both sides by coefficient. Then my L equals V over WH. And that's it. That's all it is. All right. Same thing here on the right side. C equal to 2 pi r. So that's the circumference formula for circle. Solving for r. So by only having two terms with no parenthesis, I can quickly see my 2 pi r is my variable term. Okay, there's no like term here. There's only two terms, so there's no any other like term we can combine. So since the r is a variable, that make the 2 pi the coefficient. So all I'm going to say is divide both sides by the coefficient 2 pi. So my answer, r equal c over 2 pi. And that's it. Okay? The 2 pi over 2 pi canceled out, leave me with the r. All right. I equal to PRT is a simple interest formula. So again, this simple interest formula only has two terms. So there's no terms we can combine. There's no parenthesis, none of that. So solving for r, that means it makes the PRT the variable term. So having two terms, no parentheses, variable term is already by itself. All I'm going to do is divide both sides by the coefficient. If the R is a variable, that make the P times T, or PT, my coefficient. So my answer, R equal I over P times T. Okay, that's all the answer is. All right, now this one is even easier because now this time the right side equal sign has two addition signs outside the parenthesis. So the right side alone has three terms. The left side got one term. I need to solve for A. So out of the four terms, since there's no like term to combine, A is my variable term. Okay, so since it's positive, I'm going to let it stay here. So that means the positive B, positive C got to be tossed over to the other side. So my A is equal to, on the left side, P still P. Positive B come over, become negative. Positive C come over, become negative. So the coefficient in front of A is already 1, so I don't have to say divide every term by the coefficient. So this is it. This is my answer. All right. I'm going to skip over the P equal to 2L plus 2W since I already just did one just like it, except earlier we're solving for W. Now I need to solve for L, but the steps are exactly the same. 2L is positive, let it stay. Move the 2W over, then divide every term by 2. Now this is a very important problem because the next time you see this problem will be in module 10. By then we will be learning how to solve for y. Here I want to solve for x. So I wrote something similar to this before as well in module 9.1. So addition sign here, separate between two terms. The right side 6 is a term. I'm solving for x, so the term that contains x is my variable term, which is negative 5w. Excuse me, negative 5x. All right, because my variable term is negative, so what I can do is move it to the right side. So that means the 6 got to come over to the left side. So having equal sign in the middle, negative 5x comes to the right, become positive. On the right side, excuse me, on the left side, 8y is still 8y. Positive 6 come over, move over to the left side of the equal sign, become negative. So my x is not by itself yet. So since I don't have any like term to combine, all I'm going to say here is divide every term by the coefficient 5. So my answer, x equals a over 5y minus 6 over 5. That will be my answer. All right, now let's take a look at these interesting ones. Both of these examples, I only have two terms. Ooh, sorry. So in module 4, we mentioned something about, and even before in module 9.1, I mentioned something about cross product. So I think I can use that technique here. Since I only got two terms, one of my terms is involving with fraction. J equal to K over 7M. Okay, technically I'm solving for M, so K over 7N is my variable term. But right now my variable is trapped in the denominator. So a good way to bring it to the numerator, in this two-term problem, I can use a cross product. Because if I take 7m times j, that will give me 7mj. Set it equal to, multiply diagonally. 1 times k is k. All right, I'm still having two terms. Okay, I'm still having two terms here. Right now, my variable term is 7mj because this term contains my variable m. So to get m by itself, I will divide both sides by 7j. So my answer, m is going to equal to k over 7j. Okay, that's all it is to it. All right, now for this problem on the right, let's use the same technique. Okay, and now this whole right side is one term. The numerator is also one term where I can do a distribution, which we will do in a minute. Solving for x, see my x is trapped inside the parenthesis, right? So I got to do distributive property to bring it out. So the quickest technique here is using cross product. 2 times x minus 1 multiplied diagonally, that will still be 2 times parenthesis x minus 11, set equal to 7 times r, 7r. All right. Now from here, I can either do my perform my distributive property. 2 times x, 2 times negative 11, give me 2x negative 22, set it equal to 7r. Or I can do it this way. Watch this. For the moment, I only got two terms, one on the left, one on the right. And my variable is actually here. The x is here, so since this is all one term, this becomes my variable term. So what I can do is go ahead, divide both terms by the coefficient 2. Because 2 over 2 is 1. And that 1 do a distribution will bring my x and negative 11 to the outside of the parenthesis. All right, equal sign in the middle. The right side is 7r over 2. So now my equation has 3 terms. X is still what I'm solving for, so this is a variable term. Positive, let it stay. So who do I need to move? Negative 11 need to go over. So my answer, x equals, all right, 7r over 2, still my first term on the right. Negative 11 come over, becomes positive. Okay, so this over 2 got nothing to do with the 11. This over 2 is only for the 7r. And that's my answer. All right. All right. I also showed y'all how to when we talk about division of a fraction means times a reciprocal and like that. The reason why I reviewed those concepts before is for problem look something like this. This equation here, this temperature equation only has 2 terms. So if I want to solve for f by having 2 terms, that makes the entire right side, the equal sign, just 1 term, right? There's no plus or minus sign outside the parenthesis. So I really don't want to take the 5 over 9 times my f times the negative 32. So a quick way doing this is to get rid of this fraction 5 over 9. And a good way to get rid of the fraction is times the reciprocal 9 over 5 on both terms. Why is that? Well, think about this. I'm going to erase it here in a minute. Just like I showed you earlier how I divide, how when I have 2 terms, I can divide both sides by 2. Well, theoretically, I can do the same thing here. If I would say divide both terms by 5 over 9, right? 5 over 9, 5 over 9 canceled out. That technically give me a 1 right here. And 1 do a distribution will bring my f at negative 32 out. But since I'm saying divide both sides by 5 over 9, c divided by 5 over 9 is the same thing as saying c times the reciprocal 9 over 5. So that means I went ahead and write times by the reciprocal, which is 9 over 5 on both terms. Because the 9 cancels out, 5 cancels out, so that technically leave me with a big old 1, okay, in front of my parenthesis, where I can do a distribution and thus bring my f and negative 32 to the outside the parenthesis. Now the other side would just be 9 over 5 times c, which is 9 over 5 c. So now I got three terms, but my variable term is f, positive, let it stay there. So let's move the negative 32 over. So that's why Fahrenheit is always 9 over 5 times the Celsius plus 32. Okay, that's how we do this problem. All right, same thing here. Solving for C. The whole equation only got two terms because there's no plus or minus signs outside the parenthesis. So this half times h times parenthesis b plus c, okay, is my variable term. And this formula is the area of a trapezoid formula. Okay, so let's check it out. Same technique, okay? Since my big old term on the right has a fraction coefficient in the front, so I'm going to say times the reciprocal, which is 2 over 1, or 2. Because the top two, bottom two cancels out, so that just leaves me with h on the right times parenthesis b plus c equal to 2a. So from here, I can distribute my h. Or again, I can divide both terms by h, because h over h cancels out, leave me with a big old 1 right in front of it, where I can do a distribution to bring my b and positive c to the outside the parenthesis. So now the left side would just be 2a over h. So to get c by itself, now I got three terms, because plus sign separate between two terms. My variable term is positive c, positive, let it stay there on that side, move the b over. So that gives me c equals 2a over h is still there. When the positive b come over, it becomes negative. Okay, so in this lecture video, I show you how to solve for specific variables using the same or similar techniques as what I show you in module 9.1, 9.2, and 9.3. All right, that will conclude this lecture video. Thank you for watching.